Hello my test tubes and welcome to another step preparation video. Today I'm going to be going over 2019 step 1 question 3. This is an integration question, and because I know that the camera quality is quite low, I'm just going to read it out to you. It reads, by first multiplying the numerator and the denominator of the integrand by 1 minus sine x, evaluate the integral from 0 to a quarter pi of 1 over 1 plus sine x dx. Usually, especially in step 2 and step 3, integration questions are going to introduce you to an easy way of integrating a certain type of function, and then in the second, third, or fourth parts, they're going to ask you to apply this algorithm to something more difficult than you were introduced to at the beginning. Here, however, if you look at part 2 and 3, it asks you to integrate 1 over 1 plus sec x and 1 over 1 plus sine x all squared, which isn't that much harder than integrating 1 over 1 plus sine x, or at least the function doesn't look hard. I haven't integrated yet, so I don't know. So that should be quite comforting, and that is what would make it a good integration question. So just hopping in, gosh, I actually said that, into the question itself, to doing what the algorithm asks me to do, giving 1 minus sine x over 1 minus sine squared x from difference of two squares dx is equal to 0 to a quarter pi 1 minus sine x over cos squared x dx, which is equal to the integral from 0 to a quarter pi of sec squared x minus sec x tan x. The trig manipulation here, especially with the sec x tan x, might not be obvious. So in an exam, I suggest you just write that out as sine x over cos x. Now you're like, oh look, there's a tan in there, so it's tan x over cos x. Anyways, proceeding further with this, it is a standard integral, even in A-level. Sec squared x integrates to give tan x, and sec x tan x integrates to give sec x. So that gives me tan x minus sec x 0 to a quarter pi, which is tan a quarter pi 1 minus sec a quarter pi root 2 minus 0, because tan 0 is 0, and then plus 1, giving me 2 minus root 2. The second part of the question differs, for my solution differs from the mark scheme solution. The mark scheme solution does a bunch of algebra on the integrand before actually doing the 1 minus trig function of x trick. I just don't think that doing a bunch of algebra on it before the trick is obvious to the person doing this question for the first time. So my advice is with step is just do what you're taught to do, and I'm going to do exactly that. This gives me, I'm not going to write limits, I'm going to add limits afterwards, because I'm 1 minus sec x over 1 minus sec squared x dx. Do be careful with the 1 minus sec squared x, that's not tan squared x, that's minus tan squared x, giving me the integral of sec x minus 1, just multiplying by minus 1, divided by tan squared x dx, which gives the integral of cot x cosec x minus cot squared x dx. Looking at first at cot x cosec x, that should be should look familiar, just like sec x tan x. If you don't know the integral of sec x tan x, of cot x cosec x, just look at sec x tan x. You know that sec x tan x differentiates to sec x, so cot x cosec x should integrate. Should integrate to something like cosec x. However, if you differentiate cosec x, you get minus sec x minus cot x cosec x. So this actually gives minus cosec x. Instead of integrating cot squared x, I'm just going to reformulate this in cot x cosec x minus cosec squared 1 dx. Again, cosec squared x should remind you of a sec squared integral. Sec squared integrated gives tan x, so cosec x, cosec squared x should give you something like cot x. However, if you differentiate cot x, you get minus cosec squared x. So the integral of minus cosec squared x is going to be just cot x. So this gives, and now I'm going to add the limits. Don't do that in the actual exam. That's really bad practice. This is minus cosec x plus cot x plus x in between a quarter pi and a third pi, and that gives me minus 2 root 3 over 3 plus cot a third pi, that's root 3 over 3 plus a third pi plus then cosec x is going to be 16 cosec a quarter pi is root 2. Yeah, lost my concentration there. Cot x is 1 x minus 1, minus a quarter pi, giving me minus root 3 over 3 plus root 2 minus 1 plus a 1/12 pi. For the next part, we're asked to integrate 1 over 1 plus sine x all squared. You might be wondering whether you should multiply top and bottom by 1 minus sine x or 1 minus sine x all squared. And well, some of you may find it more intuitive to multiply top and bottom by the square. Some of you might not. Just the key is to try both things. If there's two ways your answer can go, one might not work, but the other definitely will. So I'm going to multiply both sides by 1 minus sine x all squared, giving me 0 a third pi 1 minus sine x squared over 1 minus sine squared x all squared dx, which is equal to 0 to a third pi 1 minus 2 sine x plus sine squared x over cos to the 4 x, giving me the integral 0 to a third pi sec to the 4x minus 2 tan x sec cubed x plus tan squared sec squared x dx. Before I do anything, I'm going to convert the sec to the 4 to just using a sec squared x times 1 plus tan squared x, because I'm more comfortable with mixtures of tan x and sec x instead of just sec to the 4. I'm going to explain why later. This gives me 0 to a third pi sec squared x plus 2 tan squared x sec squared x minus 2 tan x sec cubed x. Now here you already know how to integrate sec squared x. You also have to functions that you might not be able to integrate. Now, for those of you who do not know, let me just try. Yes, those of you who do not know how to integrate these two, it will be helpful for you to know the integral of tan to the nx sec squared x is just a chain rule application of differentiating tan to the n plus 1 x. So your integral will be of the form tan to the n plus 1 x. Obviously, you're going to multiply by a few constants, but if you differentiate tan to the n plus 1 x, you get n plus 1 tan to the nx times the derivative of tan x, which is sec x. So do look out for tan to the nx sec squared x functions, because those are quite easy, and do look out for the constants as well. So this is going to give me 2/3 tan cubed x. And for functions of the form tan x sec to the nx, tan x sec to the nx, those integrate to give some constant multiplied by sec to the nx. Again, this is due to the fact that the derivative of sec x is sec x tan x. So if you take the derivative of this gives you sec to the n minus 1 x times n times sec x tan x, which gives you n sec nx tan x. So this is going to integrate to give me minus 2/3 sec cubed x. But do remember these for standard integrals, not just in this question. Continuing on from here, you have this is going to give you then tan x plus 2/3 tan cubed x minus 2/3 sec cubed x from 0 to 1/3 pi, giving us root 3 plus 2/3 times 3 root 3 minus 2/3 times 8, and then the limit at 0, that's going to be 0 plus 0, and then plus 2/3 times 1 cubed, giving me my final answer of 3 root 3 minus 16/3 plus 2/3, giving me minus 14/3. There we go. I hope you enjoyed this, and I hope that your exams go perfectly well.